In the previous class, we set up a UDP echo server using an existing program called xinetd. It's an existing software that has been there in Linux for many years now. And then we set up an UDP echo client in the previous class, where we used this famous program, the netcat program. Okay, so both of them are very famous, well-known programs. Now, then we said, okay, what is the purpose? The purpose that we are going to talk about only two packets. The first packet will be sent by this UDP echo client, and it will just send a request packet. So what was the content of this request packet? It will send a hello. It will send a hello, okay, to the echo server. And after, on receipt of this echo request, the UDP echo server will again reply back to the client saying, yeah, I got your hello. So we are talking about only two packets. The first packet is an echo request, and the second packet is an echo response. And we also started Wireshark, the packet sniffer tool, to actually verify that the picture that we are drawing, you know, two packets being sent and received, etc., we could actually see that this is working. Okay, so I think till here, I think it's clear. Today, what we are going to do is this. Remember this UDP echo client. So you said netcat is an existing program that we can use to, you know, use this echo client. This echo client, we need not use netcat. We can write our own program, you know, a simple C program, and this C program will easily work just like netcat. Okay, so our target today is to write a replacement for netcat. We want to write a program which works like netcat. We want to basically write a UDP echo client. Okay, and the server will remain the same. In the next class, we are going to rewrite the server also. But for today, we are just going to write the UDP echo client using simple C programming. So let's start now. Okay, so remember, instead of this UDP echo client, we are going to write our own echo client. And we just said that in order for this communication to happen between client and server, how does this communication happen? This communication cannot go in the application layer we just discussed now. So it will always have to go through the transport layer. So now what is the connection? So for example, this UDP echo client, it directly cannot, you know, go to this kernel mode. No, remember, this transport layer is in kernel mode, and this client, UDP echo client, is in user mode. So you cannot directly jump from user mode to kernel mode, is it not? There has to be some connection. And remember, what is the connection? This connection is called the socket. This connection is called the socket. So socket is the thing. Socket is the entity or the abstraction that actually connects the application layer with the transport layer. Okay. So if the echo client has to say hello, it will not say hello directly to this guy. It will not directly send it to UDP echo server. It will have to send it to the socket. Okay. This socket, you know, is connected to the transport layer. It passes to this guy and then comes out from the other socket. The other end is also a socket. So remember, this entire thing, you can imagine it's like a pipe. Okay, and the pipe passes through the transport layer. The application layer and the transport layer is connected by this opening, this interface, this opening, and that opening is called what? That opening is called a socket. Okay, that opening is called a socket. So how many sockets do we require? The client requires one socket, the client socket, and the server requires another socket, the server socket. Every socket will have an associated port number. For any communication to happen between two processes, okay, they will have to create a socket. Why socket? Because socket is the end of a pipe. It is the end of a pipe. So if you say hello here, from this pipe it will go enter this transport layer magic, and then it passes through hundreds of kilometers and comes out the other side. Okay. If it's on the client side, it's called a client socket. If it's on the server side, it's called a server socket. And each of the sockets are distinctly marked by port numbers. In our previous example, we saw that this particular port number was 58027. The client socket port number is really not important. It is a fairly large number. But on the server side, the port number is fixed. And we know for echo, The well-known port is port number 7. In the first step, let's see what a socket means. Of course, you can always look up in the internet, but we can just do man socket, and it simply says socket creates an endpoint for communication, and it returns a descriptor that refers to that endpoint. Okay, so remember, what is the socket? This is the endpoint, okay, and this is the pipe. This we already know. Every socket is associated with a port number. This we already know. Okay, on the client socket, the port number is not fixed, that is transient. Transient meaning something not fixed. Okay, the port number is not fixed. But if it is a server socket, the socket port number is fixed as per well-known port. And where do you get this well-known ports? As per well-known ports list. Where are you getting this? We are getting this from www.iana.org. From this website, we get the list of all the well-known ports. Example, for echo protocol, what is the port number? The port number is 7. We actually want to create a socket. So question is, how to create a socket in C? Okay, and the answer is, you can just go and look at the man page. It says that socket system call creates an endpoint for communication and returns a file descriptor that refers to the endpoint. Okay, so we create a socket via the socket system call. And what are the requirements for that socket? Let's take the signature. So these are the include files, and then probably this is the signature, this is the system call. What are the various arguments to the system call? The first one is domain. The thing that we are really interested in is IPv4 internet protocols. That's the one that we are interested in. Okay, because ours is the IP version 4 machine, so we'll choose this as a domain. Okay, so in our case, the domain we have selected it as this AF INET. Domain equal to AF INET, it stands for IP version 4 addressing. What's the next option? Okay, int type. Then again you can just go down into here, and here you can, from the man page, you can say the socket has indicated type which specifies the communication semantics. So clearly you can see that this thing will be applicable, this option sock dgram, because this supports datagrams, because UDP is connectionless, unreliable message. It's a unreliable message. So what we are interested is in sock datagram. And when protocols, if you do man protocols, you can look at the list of all the protocols that are supported in Linux. Okay, and that's given in etc protocols. So I can just copy this guy. Okay, so vi etc protocols. If you open this, then you can see that we are looking for UDP, no? And UDP mein what is the protocol? What is the protocol number? Here? 17, is it not? So according to this iana.org, look at what is the protocol that we are going to use. We are going to use UDP, that's our name, but in reality, if you represent it as a number, it is 17. What is protocol? What is the value of protocol? Protocol equal to 17. So now we have finally understood that to create a socket and endpoint communication, we require 3 things. First, the domain. Second, the type. And third, the protocol. The domain is fixed to be AF INET. Then since we are using a datagram UDP protocol, our type will be sock datagram, sock dgram. And the protocol, of course, is UDP. So from this etc protocols file, we figure out that this number, the protocol number, is 17. Okay, and that's how we are going to create a socket. So let's copy paste this from the main pages. So these are the 2 include files, and we are going to write a main program, and inside this main program we have to make the system call. And remember, what is the system call? This is the system call. Okay, and what do you have to put for domain? Okay, what do you have to put for domain? The first argument. The first argument will be AF INET. We have just seen it, no, from the man page. What is the next one? The type. What is the type here? The type here is SOC diagram, coming directly from the man page. And what's protocol? The protocol is 17, coming actually from the man page. 17. And remember that this, whenever we make this function or the system call, it returns an integer. And what is this integer? If you look at the man page, it says, if you look at the man page at the top, it says socket creates an endpoint for communication and returns a file descriptor. So what are we being returned? We are being returned a socket descriptor. We are being returned a socket descriptor. Okay. So let's write this down and say int socket descriptor. SD is, let's say, socket descriptor. Okay. This is the first part. And this is how you create a socket. So create a client socket. So in order for this socket, client socket, to talk to the server socket, two things are required. First, what is the IP address of this? What is the address of this server? Second, what is the port number, well-known port of this server? So let's write this down. Okay, we say, okay, so this is for server details. First, okay, we just want to say what is the server name. We know the server name is 127.0.0.1. And what is 127.0.0.1? 127.0.1 stands for local host. Second, you will have a server port. You will have a server port. And what's the server port number? 7. And why is this 7? Because 7 is the reserved, well-known port for echo protocol. Okay. So we are just seeing that in order for this client to connect to server, first it has to know which machine to connect to. That's a requirement. No, right now is the second step. Second step is to specify server details. Third part, we have to man IP, man 7 IP. Okay, section 7 of IP. And what is man IP? Man IP is the Linux IP version 4 protocol implementation. But what we are interested is in this data structure. See this here? It says that whenever you want to talk, whenever you want to connect using a socket, you have to fill up this data structure. So let's copy paste this guy. Okay, and what's the name? It is struct sock address _in. After you say man 7 IP, this is the man page, we got that the information that you have to, in order for communication to happen via socket, via the client socket, the following data structure must be filled up. In this structure, we have to fill how many elements, how many data members are there? There are 3, no? The first one is SIN family, second is socket in port, and third is socket in address. There are 3 things that you have to fill. So let's start filling this up. First say S dot, remember is if you have to access any data member of a structure, you have to use the dot operator. S dot SIN family. And according to this manual, you have to fix it. See, this is fixed. It is SIN port. But there is a very curious thing that we have to do, and we are going to talk about it in the next class. And this is port should be in the network byte order. Network byte order. The port should be in the network byte order. Okay. So we'll talk about this later. Okay. We'll talk about this later. But all I'm saying is that if we just say server port, if we just say server port here, server port is what? The value of server port is what? 7. If we just put it this way, it's going to be wrong. This is because this number that we are putting is in a different mode called the little endian mode. It's not the right one. Okay, we'll just talk about it in detail in the next class. But all you have to do is to call this function host to network byte order. Okay, host to network byte order, and then you do server port. Okay, this you have to do. So what is the function that we are calling? H host, it is H for host, then 2, then N is for network byte order, and S is for short. So let's write this down. Okay, let's write this down, I think. Okay, so in order to, so you say that family, scene family is always equal to AF INET, there is no doubt, but this port should be filled using H2NS. And what does H2NS means? It means host to network byte order short. Okay, this is a function call that you have to make. Otherwise, this program is not going to run properly. Okay, so the first one is done, this guy is done, port is done. The only thing now that remains is the address. The address. Now look at this address. This address here is in the form of a string, but whenever you are sending it into the network, it has to be always changed into binary. This string has to be converted. This ASCII string has to be, ASCII means this string has to be converted into a proper address. Okay. In order to do this, we have to go for another function, and this function, let's see, I don't know, let's see, apropos inet. Okay, we can use this function. What is the command that we have used? Apropos inet. Apropos gives you a list of all the programs and all the functions that you can call, and we are targeting this particular function, inet ASCII to network. Okay, this is, you can say man inet ASCII to this, and then so the first argument is the IP address in strings, and the output of this function, this inet ASCII to network, is actually binary IP address in binary. So you can just copy paste this guy. Okay, just copy paste this guy, and okay, and the third argument that we have to do is this. We have to use this function to convert for SIN address. We have to use which function? We have to use this inet ASCII to network. What does it stand for? inet ASCII to network. This is the function that we have to use. And what's the first argument? The first argument here, this argument here is the IP address in string. And what is the next? This guy. And what is the next one? Next one is the IP address in bytes, in binary. Okay, these are the two things. So let's make a copy of this guy and put it there in our actual code. Okay, let's put it here. Okay, what is the first argument? The first argument has to be the string itself, the server port. And what is the server port? This is a server name. Just put the server name here. And what is the output? Output will be in address. Okay, it will be like s dot sin address. Okay, and remember this has to be a pointer, so you have to put the address of operator. Okay, so the third part is also over. And what is the third step? Fill the sock address in data structure with server port and server name. These are the two things that you have to fill up. And how do you fill up? We fill up this way. Okay, and now finally we are going to send the data. And what's the fourth step? Is to send data. So how many steps are involved if you have to do the client? There are 4 steps, no? Step number 1, you have to create a, you look at the figure. Step number 1, you have to create a socket. Okay. Step number 2, you have to get the server IP address 127.0.0.1 and the port number 7. That's the second step. Third, you have to fill the details of this destination socket in a data structure. And what is the data structure? The data structure is struct sock address in. And this is the socket address, destination socket address that you have to fill in. And how do you fill in? This is the way you have to fill in. We'll talk about this guy, H2NS, how to do this. And how to do this, we are going to talk it in a next class. Okay, they are important functions, but for now you just have to remember that if you just put the server port 7 directly, it's all going to be wrong. And if you put this, if you just put this server name 127 directly, 127.0.0.1, it's going to be wrong, because the network, the transport layer and the IP layer, it expects all data to be in a specific format in form of binary. Okay, that's how all the data travels, no, binary.
Okay.
So once everything we have filled it up, now it's time to send some message, and the message that we are going to send is just hello. So you send this hello message, and in order to send this message, what is the system call we use? We use the send to command, and this is how you write the code. Okay, now everything is ready. Let's try compiling this. Okay, cc UDP client.c. What is this? Oh, string length. Okay, string length is from string.h. Okay, let's put a string.h. Okay, now let's compile this again. See, compilation is okay. No, compilation has been successful. No, if we say cc UDP client.c, then the compilation is successful. If we run it, then what happens? Nothing happens. No, you cannot see anything. But I am expecting that the data has been sent from the client, from our client. Remember this one that we did earlier. Remember, right now we are not using Netcat. No, we are using our own version. And what is our own version? UDP client. We are writing our own UDP client. But otherwise the picture should remain the same. So what we are expecting is that when we send this data, there has to be an echo request. Okay, when we, not this client, our client, okay, UDP client, the client that we are writing. But once we send this, the picture is to be the same. The echo request should go this red line, and then server should respond with a blue line, this line, okay, an echo response. So we expect that 2 packets would have been sent and received. But unfortunately, we are not able to verify. No. So is there a way to verify? Is there a way to check that our client is working correctly? The question is, I am now saying, because I have written this program, I am saying this program is working perfectly all right. Everything is just this picture. There are 2 packets, echo request and echo response, and they are perfectly fine. I am claiming. But is there a way to prove that it's actually working? Can we check using Wireshark? You put a third program, packet receiver program, Wireshark. Listen, look, start Wireshark and then verify. No. Wireshark, if there are 2 packets, echo request and echo response, the program is working. Wireshark, if there are no packets, it's not working. Is it not? That's the whole purpose.
Yes,
That's the whole purpose of Wireshark. Wireshark is used to debug network programs. We expect that there will be, if everything goes right, there will be 2 packets, no? An echo request and an echo response. Let's run Wireshark. Sudo Wireshark. We are just about to run this guy. Okay. And how do you do this? We have already done it. We have to pick the interface is any, and what is the filter we are going to use? We are going to use UDP port 7. And why UDP port 7? Because we are interested in UDP and we are interested in the echo protocol. And echo protocol we already know has port 7. So now let's start monitoring. 1, 2, 3, enter. Ting. And see, nothing is happening. Okay, the server is running, xinetd is already running, okay, in the background, but we have not connected. No, we have not connected using our client. So when we connect, we hope that something will come out. Okay, so please watch this carefully, because the moment we hit and enter, if everything goes all right, in this Wireshark, how many packets should come? There should be 2 packets. There should be 2 datagrams. One request, another response. Okay, so should we enter now? Ready? Just watch. Ready? 1, 2, 3, enter. And the moment we enter, how many packets have arrived?
2.
2 packets. The first one is request and the next packet is response.